All right, this is AP BC Calculus. We are doing Unit 9, Section 5, which is a BC only topic. We're integrating vector valued functions. So we saw in 9.4 that VVFs, or vector valued functions, are pretty intuitive based on all of our previous experiences with calculus, right? When we integrate, it's the same situation. The one caveat is that both of the components, or if you were ever dealing with 3 dimensions, x, y, and z, all 3 components, will each need their own constant of integration. So you'll need an initial value for each of the components in order to find the numerical value of the constant. So let's go ahead and work through some problems. Doing is much easier than just talking about it. So g prime of t is this vector valued function, right? We're given g of 1 is negative 3 comma 2. Let's find g of t. So we're going to get g of t by integrating, right? By integrating g prime of t with respect to t. So what that's going to look like, when I integrate negative 4t, it's going to become a negative 2t squared plus some constant that I'm going to call c sub 1. And then this is actually a 2t to the negative second, right? So when I do the antiderivative for that, I'm going to raise the power by 1, which would be negative 1, and divide by that power. So I'm going to get negative 2t to the negative first, right, plus some other constant c sub 2, right? The trick here is that they're not the same c values, right? So I now need to find c. Well, in order to find c, I know that if I plug in 1, I should get a negative 3 for this first term. So let's go ahead and say that when I plug in a 1, so negative 2 times 1 squared plus c sub 1 should give me a negative 3. Well, that's a negative 2 plus c sub 1 should give me a negative 3. My c sub 1 seems to be a negative 1, right? And we'll deal with that in a sec. For my c sub 2, right, I know that if I plug in a negative 1, I should get an output in the y direction of 2. So negative 2 divided by 1, because that's what a t to the negative first would be, right? Plus c sub 2 should give me a 2. So negative 2 plus c sub 2 is a 2. It seems that my c sub 2 is a 4. That means that my final answer is that g of t in vector component form, because that's what I'm going to go ahead and use, is a negative 2t squared minus a 1, comma, and then you could either use negative 2 times the t to the negative 1 or negative 2 over t plus a 4. And that's my answer. Right, so I had to find both of the constants of integration, one in the x component direction and one in the y component direction. All right, so you're going to go ahead and give that a try. We have f prime of t, right, and then you're given f of 2 as a value. Go ahead and find f of t. So it's okay if you're just going to skip ahead to, hey, I get it, I'm integrating, right? So when you do the antiderivative for 3t squared, you get a t cubed, right? And then this is plus a t plus some constant c sub 1. And then when I do the antiderivative for a 2t, I get a t squared plus some c sub 2. Well, now I need to use the 2 comma negative 1 to find this first point, right? So when I plug a 2 in, I should get 8 plus 2 plus c sub 1 is a negative 1. That's a 10 plus c sub 1 is a negative 1, so my c sub 1 is a negative 11. When I do the same thing over here, right, when I plug in a 2, I should get a 5 out. So 4 plus c sub 2 is apparently a 5, so my c sub 2 is a 1. Now that I know both of those values, I can go ahead and write my answer. My f of t is t cubed plus t minus 11, comma, t squared plus 1. And that's it. So again, I think it's pretty intuitive. You don't have to show a ridiculous amount of work. It's okay. Most of the time when you're integrating these, you can pretty much jump to doing it in your head. You can just say, hey, I get it, I'm integrating this, and I'm integrating this, and that's fine. You just have to remember those constants. So the instantaneous rate of change of a function f of t is given by r of t. So instantaneous rate of change of f of t is given by r of t. That's the same thing as saying that this thing, r of t, is f prime of t. That's what the instantaneous rate of change means. So this is a tricky way of me giving you f prime of t, and I gave it to you in ij notation just to kind of be a jerk. So when I do the antiderivatives, right, the antiderivative of 8t should be 4t squared plus c sub 1, right, whatever that is in the I direction, right, plus, so this is a 4t to the negative second. When I do the antiderivative, I'm going to get that this is a negative 4t to the negative first plus some c sub 2 in the j direction. Again, the I and j are just directions. So when I go to plug in the points that I know if if I plug in a 2 for t, I should get a 20 out of this one. So I'm going to go ahead and say that if I plug in a 2, I get 4 times 4 plus c sub 1, and that's apparently a 20. 16 plus c sub 1 is a 20, so my c sub 1 is a 4. When I do the same thing here and plug in a 2 for t, I should get a 1 out. Well, this is a negative 4 over a 2, because that's what a t to the negative first would be. It would be on the bottom, right? Plus c sub 2 is apparently going to give me a 1. So negative 2 plus c sub 2 gives me a 1. Seems my c sub 2 is a 3. So I'm then going to write f of t equals 4t squared plus 4 in the I direction, right? Plus this negative 4 over t plus a 3 in the j direction. But that's actually not what I was asked to find. I was asked to find f prime of negative 1, or sorry, f of negative 1. So I'm going to go ahead and plug negative 1 in, and I'm going to show you a shortcut in a sec that you could figure this out faster, and I'll show you how it would work if you'd like. So if I plug a negative 1 in, this is going to be a 4 plus 4, so that'll be an 8i, right? Plus, if I plug a negative 1 in here, that's going to be a positive 4 plus 3, so that's a 7j, and that's the answer they want. Now, there is another way to do this, right? So, so there is an alternate method, right? There's an alternate method to do this. So you know, right? Essentially, what you could do is the first fundamental theorem of calculus, right? You know x of 2 and y of 2. So you could find x of negative 1 and y of negative 1, right? So there's a couple different ways. So one way to think about this, right, is you could think of this as being x prime of t and this as being y prime of t. So the other way to do this, if you want, is you could say, hey, I get that x prime of t is an 8t plus 1, probably. Oh, just an 8t, my bad. Sorry, just an 8t. I got the 1 from the constant integration, my bad. And I get that my y prime of t is a 4t to the negative second, right? I know that x of 2 is a 20. I know that y of 2 is a 1. And I seem to want x of negative 1, question mark, and I seem to want y of negative 1. So another way to do this, just throwing this out there as an alternate option, and you certainly don't have to do it, is you could do the first fundamental theorem of calculus. You could say, hey, I get it. If I integrate from negative 1 to 2 of this 8t dt, I would get x of 2, which is something I know, minus x of negative 1, which is the thing I want. So if I move the x the x of negative 1 over and subtract the integral, I could actually just integrate and never find the constant, right? I could just say, hey, I'm not going to bother to find the constant. I'm just going to integrate this thing. And I'll just show you it comes out the same. You could do the same for y. So my x of negative 1 would be the 20 I have minus a 4t squared evaluated from negative 1 to 2. So this is a 20 minus, in parentheses, this will be a 16, right, minus a 4. So I get that this is a 20 minus 12, which means I get that this is an 8, right? So that's the x direction. And then I could do the same thing, and you'll see in a sec that I get an 8 at the top too. So there's my x direction, see how I got an 8. And you could do the same thing with y, right? You could say, hey, I know that if I integrate from negative 1 to 2 of this 4t to the negative second dt, I'm going to get y of 2, which is the thing I know, minus y of negative 1, which is the thing I want. If I solve for y of negative 1, I get that it's y of 2, a thing I know, minus an integral that I can find. And again, you don't have to do this method too. I'm just showing you another option, right? So y of negative 1 would be a 1 minus, this is going to end up being a negative 4 over t evaluated from negative 1 to 2. So it's a 1 minus. When I plug in the 2, I get a negative 2 minus, when I plug in the negative 1, I get a 4. So I'm going to get 1 minus a negative 6, which is how we get 7. And if you look at those, this is the x component, this is the y component, that would mean that my f of negative 1 would be 8 in the x direction, so 8i, plus 7j in the y direction. And again, just to pop up to the top, you'll see it's the same answer. I think that the way I did it the first time is a little bit easier, but certainly I'm just presenting you with an alternate method. All right, so here, same situation, right? So the instantaneous rate of change of g is given by r. That's saying r is g prime of t, right? You're given g of 1, you're asked what g of 4 is, right? So Again, I'm going to stand by what I did the first time with finding the constants. I think that was actually the easier option, but it's up to you what you want to do. I get that g of t is what's going to happen if I integrate this stuff. Since this is a t to the 1/2, I'm going to get that this becomes a 2/3 t to the 3/2 plus some constant in the I direction. And when I integrate this, I'm going to get a negative t cubed plus some other c, right? So c2 in the j direction. I'm then going to use, I'm going to go ahead and use what I know these values are, right? I know this should be a 3, like when I plug in a 1, this is a 3. So 2/3 times 1 plus c sub 1 is apparently a 3, right? So c sub 1 is 9/3 minus 2/3 or 7/3. And I get that that's like not the most fun thing in the world, but there it is, right? Same thing here. If I use the 1, I should get a 10 out, right? So negative 1 plus c sub 2 is apparently a 10. So my c sub 2 is an 11, right? That means that g of t is 2/3 t to the 3/2 plus 7/3 in the I direction, and negative t cubed plus 11 in the j direction, right? And then I was asked for g of 4, so my g of 4 is going to be a 2/3 times a 4 to the 3/2, which we'll get to in a sec, because you should be able to do that, even though I'm sure you're not loving it, in the I direction. And then this would be a negative 64 plus 11 in the j direction, right? So 4 to the 3/2, right, just as a like side note for a little bit of work, 4 to the 3/2 is the same thing as the square root of 4 to the 3rd, which is a 2 to the 3rd or an 8. So this is an 8, meaning I get 16/3 plus 7/3 in the I direction, plus this should be a negative 53 in the j direction, right? So when I clean this up, I end up getting 23 over 3 in the I direction and a negative 53 in the j direction. And that's my g of 4. And again, you could have got another option for how to do that, but I think that's probably the easiest choice. All right, so we're given f double prime of t. We're asked, and we're given initial values for both f prime and f. We're asked to find f of t, so we're going to have to essentially integrate twice, right? We're going to, so my f prime of t should be what happens if I integrate each of these. Well, this is going to be, so to integrate cosine, right? When you integrate cosine, if you picture it this way, derivative of sine is cosine, derivative of cosine is negative sine, derivative of negative sine is negative cosine, and then it loops. So this is deriving and up is integrating. So to integrate cosine, I'm going to get a sine, but because of this 5t on the inside, I'm going to have a 1/5 sine of 5t plus some constant c sub 1. And then this is just going to be a negative t squared plus some constant c sub 2. So that's not awful, right? And then I'm going to go ahead and plug in these values. I know if I plug in 0, I'm supposed to get a 3 and a 2. So if I plug in 0, right, I'm going to use f prime of 0 equals 3 comma 2. And I'm going to recognize that this would be a 1/5 sine of 0 plus c sub 1, and that should give me a 3. Well, that just means c sub 1 is a 3 because the sine of 0 is 0. And if I plug in here, I would get negative 0 squared plus c sub 2 is a 2, so c sub 2 is just a 2. So now I have f prime of t as 1/5 sine of 5t plus a 3 and negative t squared plus a 2. Right, so then I'm going to do the antiderivative one more time, right? F double, sorry, not f double prime, just f. Come on, brain. So f of t is going to be, now when I do the antiderivative again, the antiderivative of a sine, so if we go back up here, here's sine. I'm going to loop to negative cosine, but again, I'm going to have to divide by 5, right? So this is going to end up being a negative 1/25 cosine of 5t plus a 3t plus some new c that I'm going to call c sub 3 because I've already used the other numbers because I need a new constant. This is going to be a negative t cubed over 3 plus a 2t plus, I'm going to go ahead and call it c sub 4, right? So now I'm going to have to use this point, right, the 8 and negative 1. So I'm going to have to use f of 0 is an 8 and a negative 1. So let's see what we get, right? So when I plug in 0 here, this is going to be a negative 1/25 times 1 plus 0 plus c sub 1, and it's apparently an 8. So that's super fun times, but we're going to deal with it, right? So c sub 1 is apparently an 8 plus a 1/25. 8, if you times by 25 over 25, 8 is 200. So this is 200 plus 1 all over a 25. So my c sub 1 is a 201 over 25. Good times. Oh, sorry, c sub 3, my bad. C sub 3. Okay. when I do the same thing here, right, when I plug in a 0, I'm supposed to get a -1. Well, if I plug in a 0 here, this one's not so bad. 0 plus c sub 4 is a -1. Hey, that's not bad. C sub 4 is -1. Great. Okay, so then my answer is that f of t is -1/25 cosine of 5t plus, I think it was a 3t, plus 3t plus 201 over 25, good times. And then here I had a t cubed, sorry, negative t cubed over 3 plus a 2t minus a 1. And there's my f. Admittedly, that one fraction turned out kind of ugly, but it's all right. Okay, so let's go ahead and try a p3. Same idea, right? You're given g double prime. You're going to do the antiderivative twice, and each time you're going to have to plug in to find c. So g prime of t is going to be a 1/2 e to the 2t, right? Because when I integrate e to the 2t, I'm still going to get e to the 2t, but then I have to divide by the 2 because essentially doing the reverse of the chain rule, right? Plus some c sub 1, and this is going to be a 5t plus some c sub 2. So then I'm going to have to use this point, right? So I'm going to use g prime of 0 equals 4 comma -3, right? So when I plug in 0, I should get 1/2 times 1 plus c sub 1 equals a 4, right? So I get that c sub 1 is 8/2 minus 1/2 or 7/2 or 3.5, I don't care which, right? And then when I plug in a 0 here, I get 0 plus c sub 2 equals -3, so my c sub 2 is thankfully just a -3. So g prime of t is 1/2 e to the 2t plus 7/2, comma 5t minus 3, right? When I do the antiderivative again, right, so that means my g of t, this is going to end up being a 1/4 e to the 2t, right, because I'm going to have to divide by 2 again, right, plus 7/2 t plus, I'm going to call it c sub 3. And this is going to end up being a 5/2 t squared minus a 3t plus, let's call it c sub 4. So now I need to use g of 0 is 1 comma 9. So I'm going to use g of 0 is a 1 comma 9. When I plug in zeros, right, I'm going to get 1/4 times 1 plus 0 plus c sub 3 is a 1. 1/4 plus c sub 3 is a 1, so c sub 3 seems to be 3/4, which is not awful. When I plug in 0 here, I get 0 minus 0 plus c sub 4 is a 9, so at least that one's just a 9. So then my final answer is that g of t is going to be 1/4 e to the 2t plus 7/2, t plus 3/4. That's all going to be my x component, comma 5/2 t squared minus 3t plus 9. Okay, and there's my answer. So again, I had to find those constants each time. All right, so here we're allowed to use a calculator, and this is actually really similar to the other way that I did one of the first problems where I said you could sort of lean on the first fundamental theorem of calculus, but here that's definitely what we're going to do. So we know if this is our h prime of t, let's go ahead and call this x prime of t, and this is y prime of t. So we know x of 1, and we know y of 1, and we seem to want, right, what we want is x of 3 and y of 3. Well, that's a first fundamental theorem of calculus problem, right? So if I integrate, x prime of t dt from 1 to 3, right, I'm going to get x of 3, which is the thing I want, minus x of 1, which is the thing I know, and this is a thing I can make my calculator do. So I'm going to go ahead and add that x of 1 over, so I'm going to get x of 1 plus the integral from 1 to 3 of, and I should write the function they gave me to get full credit, so this cosine of t squared, right? And that's going to give me my x of 3, right? And I can use my calculator to get that because I know x of 1 is a 2, because that's the x coordinate here, right? Plus this thing I'm going to find in my calculator, and that's going to give me my x of 3, and I can get an approximate value for that, right? So I actually went ahead and put these in as y1 and y2 in my calculator already. So I'm going to go ahead and do 2 plus, and I'm going to do math 9, because I want to integrate, right? Vars over to y vars, and I want to pick parametric, and I want x1t, comma, with respect to t, from 1 to 3. Oh, my bad, to 3, and hit enter. And that's the whole value, right? Because I included the 2 in my typing, right? I included this value in my typing. So that's going to be my approximate x coordinate. And then honestly, I'm going to kind of cheat and say that I can just kind of copy my own work here, but for the y, right? Y of 1 plus the integral from 1 to 3 of the y prime function, right, should give me y of 3. Like, I don't need to reinvent the wheel. I don't need to logic through that again. I can go ahead and find it, right? So y of 1 is a 6, right? So that this is a 6. So I can go ahead and hit second enter, and I can replace this with a 6, right? And I can replace the x1t. So I go to vars over to y vars. I want parametric, and I want y1t. And I hit enter, and I get that this is about a 13.510, right? So then my answer, right? So for my answer, I need to say that h of 3 is approximately 1.798, comma 13.510, right? Because it's a vector. They asked for the vector. They wanted h of 3. They didn't ask at any point about x of 3 and y of 3. I use that notation myself. So that's the idea. All right, let's do one last problem. So here we have that same situation where you're given a k prime and you're given k of 2 and you want k of 10, right? So let's just go ahead and call this x prime of t, right? And this is y prime of t. And so that means that this is x of 2 and this is y of 2. And what we seem to want is x of 10 comma y of 10, right? So we're going to essentially apply that first fundamental theorem of calculus twice, right? So if I integrate this negative sine of 5t with respect to t from 2 to 10, I should get x of 10, right, because this is x prime, minus x of 2. And I know x of 2, so if I add the x of 2 over plus this integral from 2 to 10 of the negative sine of 5t dt, I should get x of 10, right? So I'm going to be able to type that in my calculator and get an answer. And then by the same token, I can do the same trick with y, right? So y of 2 plus the integral from 2 to 10 of that y prime, which was the natural log of t squared plus 4 with respect to t, right, should give me y of 10, and I type both of those in, and I get those values, and that's going to give me my answer, right? So we know x of 2 is a negative 1. We know y of 2 is a 4. So when I type those in my calculator, I should be able to find those values. And this is what I need to write to communicate understanding, right? Not the calculator notation. So I already put those both in my calculator, so I'm going to go ahead and quit out, right? So I'm going to go to math. Actually, before we math 9, I'm going to type in the negative 1 plus math 9, right? Function integrate. I want to go over to vars, y vars, pick parametric, and I want, vars over to y vars, parametric, and x1t, comma, with respect to t from 2 to 10, right? So 2 to 10, and I close that and hit enter, and I get this is approximately a negative 0.639, right? And then I'm going to hit second enter, because why not? And all I need to do is change this to a 4. So it's a 4, and then delete that extra 1, and change this x1t into a y1t. So parametric and then y1t, and that should give me my answer. And I get that this is a 32.637. So then my answer, and I think this time it was k, but we'll double check, k of 10, is that k of 10 is negative 0.639, comma, 32.637. And that's it. And that's it for this video.